Hello YouTube, this is UMLs03. So now we're on to lesson 22 of the Python curriculum, okay? And essentially what we've been talking about is intermediate level data structures, okay? So we're distinguishing some important ones for Python, but I wouldn't go so far as to say that they're groundbreakingly difficult. But what we're doing is we're trying to compare and contrast lists, tuples, sets, and dictionaries. And we've been talking about lists a whole lot, tuples a fair amount, and then sets certainly a little bit, and then dictionaries just a tiny bit. So let's go ahead and clear that up. With regard to lists, if you have some list L, some element E, and some index position I, you can access an index position by L of I. You can add, remove, or change elements. You can say L.append V, that would add it to the end. L.insert of IE, that would insert element E at index position I. L of I equals E, it would assign index position I to element E, right? Basically, E would now occupy that index position. L dot remove of V would just remove that element. You can do L dot index of E, that would tell you the index position of the first occurrence of E. It'll throw an error if E does not exist within the list. You have L dot count of E, that'll determine the number of times E exists within the list. L dot reverse, that would just go ahead and flip the order of the method of the elements, and you just go ahead and call that on the line by itself. Length of list, len of list. That's not a constant that can change if you add or remove elements. L dot clear, that would remove all elements from the list. Tuple of list and set of list. So what you can do is you can actually make a tuple out of a list. So if you look here, it says list1 equals 420, so that's a list. But here it says tuple1 equals tuple of list1. So this creates a variable called tuple1, and it sets it equal to the tuple representation of list1. So tuple1 is a tuple. So now what do you think would happen? What would you think would happen now if you tried to say tuple1 of 0 is equal to 5? Okay, so basically now if you go ahead and try to run this code, I think we basically threw an exception in a previous lesson, right? But we know that we're not allowed to, it does not support item assignment, okay? But that's tuple of list and set of list. So you can also convert a list into a set, and basically that would remove all the duplicate elements. So what if you say list2 equals 4, 4, 4, 7, 5, and then you say set2 equals set of list2, okay? So then you can basically do that. So we're just trying to move along here. So set of list2, and then we can say print of set2, okay? And basically what you're gonna see is that all the duplicate elements get removed. So basically you just are going to have, let's see, we're still having an issue. There's an exception here, right? So it was basically preventing the rest of the code from running. So now if we go ahead and run it, you just see the 4, 5, 7. Okay, so these elements are not ordered, and you cannot access them by index position, okay? So that's tuple of list and set of list, okay? And then you can also concatenate two lists using plus or times. And then you can check if an element belongs to the list. Remember, we could say if E in L, or if E not in L, or if not E in L, right? Basically, so you can combine those kinds of things. And then have ands and ors there too, right? And then tuples. For some tuple T, element E in index position I, we can access an index position T of I. We can determine the index position of the first occurrence, T dot index of V, just like with lists. We can determine the count of an element, T dot count of E, just like with lists. We can get the length of a tuple, just like with lists, but this time it's obviously a constant, right? Because we can't add or remove. We can have list of tuple and set of tuple. So just like we can convert a list into a tuple, we can convert a tuple into a list. So now we could say fun list, right? Is we could say basically we could say list of, and then we could basically have a tuple argument. So what if you had 5, 6, and 2 in here? And you could see how basically you can accept a tuple into the list function, and it will basically return a list. So now if you go ahead and say, now you can go ahead and change the elements, right? So you could go ahead and but you can just print it and you get the idea, right? So if you pass a tuple in here, and more commonly, we could have done an example with a tuple variable, right? But if it's a tuple, the point is that you say list of tuple, and that returns a list representation of the tuple. So now we can change elements, add them, and remove them. And we can also do set of tuple. Okay, so if you have elements in your tuple, then the set of tuple will give you a set. Okay, so it will remove the duplicate elements, but now you will be able to add and remove unique elements. Okay, we're going to talk more about sets in a second. So we can also concatenate two tuples using plus with two tuples, or times if you have an int in a tuple. So that's the same thing with lists. You can see there's some similarities and differences, right? And then you can also check if an element belongs to a tuple. So you could say if E in T, or if not E in T, or if E not in T, right? All those are valid. Let's talk about sets. For two sets, S and T, right, and some element E. So hopefully you're keeping up with that, right? These are just I'm just calling things arbitrarily. So if you say S dot add of E, this would basically go ahead and add the element E to the list. Okay, so otherwise adds E to the set, right? So just add the element to the set. But then if E is already in S, doesn't do anything. S dot remove of E throws an exception if S does not exist in S. Otherwise removes E, right? And then you can get the length of a set. We're going to say that's not constant because of the first two things we just talked about. S dot intersection of T. This returns a set with all elements that are in S and T. I think we saw that in the previous video, and we only got one number, right? I think if we scroll up on the console, remember we returned a set which was just the intersection of the two sets. And I think we ended up just getting this 10 here, remember, from the previous video. And then we had S dot union of T. I think we actually called that before S dot intersection. So S dot union of T would return all the elements that exist in at least one of the sets, okay, but they don't have to be in both. So obviously S dot union of T would return at least as many elements as S dot intersection of T, and probably more. S dot is joint of T will return true and if and only if no elements belong to both S and T. Okay, so if there's not a single element that's in both S and in T, then basically this is a Boolean that returns true. S dot is subset of T returns true if and only if all elements of S exist in T. S dot is superset of T is the opposite, so that would be if all elements of T exist in S. S dot clear can remove all elements from the set. We can also check to see if an element belongs to the set. So we could say if E in S, okay? We can also go ahead and convert a set back to a list or to a tuple. Okay, so let's go ahead and convert a set to a tuple. So what if we say set equals 8, 10, 8, 10, 12. Okay, so you can see there's no issue with that. But then what we're going to do is we're going to say basically basketball equals to, I don't want to call that set. We're going to call it baseball. It's going to be a set, okay, because this is set notation with the curly braces, set, okay. But then we're going to say basketball is equal to tuple of baseball, okay. So now what you can do is you can say print of basketball, and so now hopefully we'll have a tuple with 3 elements in it, right, because it got boiled down to 3 elements when we said that baseball was going to be a set. So hopefully that makes sense to you. And it's a tuple, so there's no adding or removing or doing anything with these 3 elements. Those are your elements. But we do have index positions for them now, right? So now you could say basketball of 0, right? And you would get 8. So those are basically sets, right? So you can have list of set and tuple of set, and the same thing with the Boolean. If E and S, just like we had if E and T for a tuple, just like with if E and L for a list. Dictionaries are interesting. So it's a set of key value pairs. So we said basically it's these matchups. So you're going to have these colons that connect a key to a value. And so basically what can you do? You can access by key. You can access an element in the dictionary, access a value in the dictionary by key. So you could say D of K, and that would give you the value that's paired with that key K. It would be equivalent to if you said D dot get of K. Okay, you can also say D dot get of KV. So if you pass in 2 arguments into get, if K is not yet in D, if that key doesn't belong in the dictionary yet, then basically it would create that key value pair. So it would say, okay, I'm going to give this value to this new key, right? It's going to be a new relationship. But regardless, you're going to return D of K. Okay, so it would return the value there, you know, and it might be something new, or it already, you know, is a thing, and it would give it to you. And then D of K equals V would either reassign the value of key K or add the key value pair. Length of D would return the number of key value pairs in the dictionary. List of D dot keys or tuple of D dot keys or set of D dot keys returns the keys in a dictionary. So let's come down to here. What I'm going to say is I'm going to say green dictionary, and I'm going to say basically we can map things. So we can map this string A to a 4. We can map the number 6 to a 10. We can map the Boolean true to a 5.2. So you can certainly mix and match data types. What you might remember is when we were talking about the range function, we said that was really helpful when we were working with a for loop. We can say for y in range of 5, print y, and that will print 0, 1, 2, 3, 4. But remember, if we say just print range of 5, that's not very useful to us, right? And it just says range of 0, 5. And the same thing would happen basically if we basically say green dictionary dot keys. So then basically what's going to happen is you'd think that it's going to return the keys that belong to the dictionary, but it just says sticked keys. So what you do is you basically make a data structure out of it. So you could say list of green dictionary dot keys. Okay, you could also do a tuple of green dictionary dot keys, and that would just give you a tuple, and you could set that equal to a variable, and then that variable would just be equal to the tuple with the keys from this dictionary, right? You could also do a set. Why can you do a set of keys? Because the keys have to be unique. So this is actually a really fitting operation here, a set of keys. Okay, so that's for dictionaries. Okay, you can also do list of d dot values, or tuple of d dot values, or set of d dot values, and that would return all the values in the list, values in the dictionary as a list, tuple, or set. You can also say d dot update of, and then you can pass in basically these curly braces in a particular key value pair, so k colon v, and that's equivalent to d of k equals v. If you say d dot pop of k, that's going to remove that key value pair, so it'll find the key and remove that key value association. And then if you say d dot clear, that will remove all key value pairs from the dictionary. And then we can also say list of d dot items, or tuple of d dot items, to return tuples for the key value pairs. So let me show you what I mean by that. We're going to say print list of green dictionary dot items. Okay, and so what this is going to do is it's going to return a list of tuples, and in each of those tuples it's going to have two elements. One is a particular key, and then one is the value that was associated with that. Another key, another value, another key, another value. So that's a list of green dictionary dot items, but you could have decided to make that a tuple of green dictionary dot items. Okay, oops, so I pressed the wrong button here. So now if you go ahead and run it, you can go ahead and get the, you can go ahead and see it's a tuple of tuples now. Okay, so we can search, just like we can have a list of lists, we can have a tuple of tuples. What I want to talk about now is list comprehensions. So basically we have code that basically where we could basically create an empty list, and then we could say for x in range of UVW, and we know how range of UVW works, right? So x equals u first, you know, then x equals u plus w, then x equals u plus 2 times w, right? And don't forget the order of operations. And then dot, 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 you know, as long as x is less than v. Okay, so that's the Boolean that it runs. And so basically what we're going to do is we're going to say if b, so it's going to check a particular Boolean for each of those values of x. And if that Boolean is true, we can say list.append of f of x. So basically it's going to run through some values of x, or, you know, some operation on x. And if a particular Boolean is true for that value of x, then it'll basically add a value to the list. So this is a way of generating a list, but we can actually do all of this code in one line, and that's called a list comprehension. So let me show you what I mean. What we can do is we can say list comp1. What we're going to do is we're going to say x plus 1 for x in range of 4. So what this would do is you think about x in range of 4. So that would be 0, 1, 2, and 3, right? And so this would just do x plus 1 for each of those values of x. So then you can go ahead and run main.py, and you get, gee, where are we? So we have to print it, right? So we would have to say print of list comp1, and then we can go ahead and see what is the output here. So this would give you the, let's see, why are we not running it? So print of list comp1. Oh, this is not at the bottom of the code. It's going to be hard to find, right? So I just wrote so much damn code here. So let's go ahead and put this at the bottom. Okay. So now basically you see the 1, 2, 3, 4. Okay. What if you had said x times 2 for x in range of 4? Okay. And so now you would go ahead and get 0, 2, 4, 6. Okay. Because it would be 0, 1, 2, 3, but times 2. So hopefully that makes sense. Remember, we said it doesn't make a difference if you say list of range of 4, and sometimes that actually makes things a little less ambiguous, because now this is actually literally a list. Okay, it could actually work for a tuple of range of 4, right? Because as long as you're not changing the values, you're still plucking out the 0, 1, 2, 3. So that would actually work out for you. And then you can call the variable whatever you want. So you could say rat times 2 for rat in tuple of range of 4. but it just has to make sense within the context, right? And you don't have to just do range of 4. You could do range of 4 to 10, right? And we talked about how if you plug in different sets of inputs into the range function, it does different things, okay? And so basically you can see what's going on there, right? It's taking 4, 5, 6, 7, 8, 9, okay? And it's printing that times 2, okay? And then basically we can also put a Boolean in here. So we could say something like if rat is greater than 6. So then what if we put this Boolean in here? So we know that rat is going to take the values 4, 5, 6, 7, 8, 9. But now we have an extra Boolean in here that imposes an additional restriction. So now we have an additional restriction on elements that get added to our list. And so that's basically what we were saying with the, if B, okay? So we can put basically an extra restriction beyond just the range things, right? Because the range thing certainly makes you finite, but you can also have a Boolean that will restrict values within that range, okay? And so it'll only append the element to the list if this particular thing is true, right? So now if we run this Boolean, now we only get 14, 16, or 18, right? And then obviously you can combine Booleans. So now if you say false, you're going to be looking at an empty string, right? Because it's not going to add anything. We can also talk about a formatted string. So basically what happens is you can have a sequence of this is the format that it takes. So this is basically a way of formulating a string, and you can do it basically with referencing different strings. So here's what you do. Basically, you're going to have a sequence of essentially index positions. And basically what I mean by index positions is that you're going to be referring to these arguments in order. Okay, so basically if you say 0, 1, 0, 2 here, basically what you're going to do is you're going to have one occurrence of letter 1, because this is basically like the 0th argument to the format function. So you would do letter 1, which is a capital A, okay, and then you would look at here. So now we were just said 0, so we have to look at the first argument, and then we see a 1 here. So now we're going to look at the next argument. So it's a D, and then we see another 0. So we're going to go back to A. So it's going to be A, D, A, and then we have a 2. So now we actually have to look at the M. Okay, so basically the way I tried to describe it is it's a sequence of the letters in the order that you want. Okay, so this is basically the sequence in the order that you want. And then basically that just maps to basically keys, right? It's a sequence of letter keys over here. Okay, and so you can call these whatever you want. And I basically, in my example, I have one example where I pass in a variable, and the other ones where I just pass in, strings actually. What if I wanted to print an additional line? What I could do is I could go ahead and insert a 3 here, and then I could have a string that's comprised of an escape sequence. So now that would go ahead and print something additional, right? So hopefully that makes sense to you. But I think what I'm going to do is just clear all this code, because I think we've talked enough about data structures, and hopefully you have a good understanding of how they work, and you're going to be practicing everything that we discussed earlier in this video. But what I could do is I could say something like print of 0, 3, 0, 1, right? And then you could say dot format. You have to basically take a string, and you have to have these curly braces, and you have to put integers in the curly braces, and the integers need to line up with the ordering of these string keys, which are basically the inputs to your format function. Okay, so now I don't even know really what I'm doing here, but what you could do, I guess if you wanted to say Adam at this point, you would think, well, now I need to put an A at index position 0, so I'm going to have A be first. And then I would need to make D index position 3, so I'm just going to have 2 commas, right? And then D is going to have to go way over here, right? And then with regard to 2, that could be anything, right? This could be anything. Doesn't get called, right? This doesn't get called, so it doesn't matter. And then you could go ahead and put an M in index position 1, because you can see that the last letter that we reference is basically an index position 1 of these arguments. So you want to think of the arguments to the format function as a list, okay? And basically this is going to call on those index positions of those arguments one at a time in that sequence to generate your string. So now if we go ahead and run it, we have an issue, so we need to close off that quotation. We need to close off that quotation right there. That's a syntax error. And now it just says Adam. So hopefully you understand that, right? And then we could have done one more thing. So what if we could put a 2 there, and then we make this an escape sequence, right? And then it would go ahead and print a new line. It would print an additional line. So you say print of A, and we would get an additional line. And so you see an additional line printed there. So hopefully that was interesting. From emails03, thanks for watching and please subscribe.